Assalamualaikum and hello, my name is Moha Shamsudin. Today we at my team Izmir Moha will present on the fatigue test for ceramic and metal. The main objectives were to compare and analyze the mechanical properties of a ceramic and metal by conducting a fatigue test. We also need to demonstrate the use of the fatigue testing machine for testing specimens subjected to cyclic loadings. So what is fatigue testing? A fatigue test is used to evaluate if a material can sustain cyclic fatigue stress. The material is chosen by design to meet or exceed the service loads expected in fatigue testing application. The fatigue process consists of three stages: initiation, propagation, and final rupture. For this test, the materials chosen are silicon nitride for ceramic and aluminum alloy for metal. Silicon nitride is a chemical formed by combining the element silicon and nitride. Silicon nitride produces high-quality components for use in extremely demanding applications because it can withstand the rigors of severe thermomechanical and porous situations. Silicon nitride has superior properties such as high hardness, lightweight, high temperature stability, hardness, and wear resistance. Cutting tools, engine components, bearings, and metalworking are all examples of silicon nitride applications. As for aluminum alloy, it is a precipitation hardened aluminum alloy with the main alloy ingredients magnesium and silicon. This material has excellent corrosion resistance and moldability. Aluminum alloy is commonly used in heavy-duty construction such as rail coaches, truck frames, shipbuilding, bridges, towers, pads, and even aerospace applications such as helicopter aeroplanes. In the report, these are the topics that were discussed on this content. The factors that can affect fatigue strength are the stress concentration, surface roughness, surface condition, and environment. The endurance limit of the material is the maximum stress that can be applied to the material. Cycle to failure is the number of cycles before a cycle fails. A bending moment is a force that causes the cycle to bend. Cyclic stresses are the occurrence and distribution of forces exerted on the material. Structural changes in fatigues are where crack initiation first occurs. Crack initiation and propagations are stationary propagation are the fatigue surface generated by steel patches. Nucleated propagates for certain metals. Fatigue crack growth rate precedes change of temperature. At stage 2, fatigue crack propagation is a function of not only stress and crack size but also material factors. And the other two topics were stress and crack length to fatigue crack propagation and vice versa. And then the last but not least is the fatigue crack propagation rate. I will now pass it on to Izmir for methodology and results.
Thank you, Haziq. Now we will proceed to the methodology part. The methodology part consists of three parts, which is apparatus and materials, experiment setting or parameter, and procedure. Okay, now we are going to the apparatus and materials. For the experiment, we use the rotating bending testing machine, which is the MT3012-E fatigue testing machine. For the specimen, we use silicon nitride for ceramic, and we use aluminum alloy 6061-T6 for metal, and we use vernier caliper. This is the rotating bending testing machine. So experiment setting and parameter. Applicable testing standards include ASTM E739-10, ASTM E647-15E1, ASTM E606, ASTM E466, ASTM E468, ISO 12106-2017, and DIN 50100. Let's go into the procedure. First, we need to prepare the ceramic and metal specimen with the stated dimension. Adjust the spring balance so that the load application assembly is harm-friendly on the spring balance. Leave the load application bearing and insert the metal into the bearing. Then insert the large end into the specimen grip and tighten the grip with wrench. Next, apply 225 Newton load by tightening the load's adjusting screw. Next, we set the revolution counter to 0 by pressing the tear button. Next, there are two coil springs around the columns to protect the spring balance when specimen fails. Free the set screw above the coil springs on the columns. Then we reset the set screws on the column such that the coil springs are not compressed. Okay, we turn on the motor by pressing the green button. Line will record the number of revolution from the speed indicator when specimen broke and fails. Then we will repeat this experiment by replacing the metal with ceramic. Level, we plot the maximum stress level versus the SN curve. Okay, as you can see, this is part of the experiment setting. We have the maximum revolution is around 1 million, and the revolution per minute is 3000 rev per minute. The dimension is 15 mm diameter and 210 mm in length. Next is the result. So for the result, this is the graph stress versus number of cycles for ceramic specimen at room temperature. And next, this is the second graph, stress versus number of cycles for metal specimen at room temperature. So that's all for me. I'll pass to Moha. Thank you.
Hello, today I'll be following up my group member. I will do discussion and conclusion for our experiment 3 fatigue stress. Highest stress obtained from the metal was 2,500 megapascal. Meanwhile, the highest stress obtained for the ceramic is 280 megapascal. The fatigue limit of steel is observed to be 10 to the power of 8 number of cycle. Meanwhile, the fatigue limit for ceramic is 10 to the power of 7 to 10 to the power of 8 number of cycle. The stress graph for ceramic is seen to be close to linear. Meanwhile, the stress graph for metal specimens observed to have a steep gradient in the curvature around 10 to the power of 3 to 10 to the power of 4. There's a curvature there for stress graph for ceramic steel. Meanwhile, stress graph for ceramic, there's a straight line, almost a straight line, just a very little curve, a gentle curve. For our experiment, we use aluminum alloy 6061-T6. Strong aluminum alloy that is mixed with ferroatom is a highly alloy and intensely heat treated to make it suitable for structural reason. It's also one of the most common aircraft alloy. The process involved to produce this alloy is mixing with ferroatom while rolling in the alloy sheet while it's hot. Next is our conclusion for experiment. In conclusion, we fulfill our objective to compare the mechanical properties of silicon nitride with the ceramic and aluminum alloy 6061-T6, which is a metal by conducting fatigue stress. And the second objective is to analyze the mechanical properties of the ceramic and the metal alloy by conducting fatigue stress. From the experiment, we get the highest value of stress is from a metal, our aluminium alloy 61-T6, and the value is 2,500 megapascal. The ceramic suffer fatigue failure much quicker compared to metal because ceramic is brittle in nature. Meanwhile, metal is ductile and can undergo plastic deformation before failure, meaning it will last longer and absorb more strength before it collapses. From the data we obtained, we can conclude that metal has generally better fatigue stress than ceramic. The ceramic specimen has the lowest stress around 10 to the power of 7 and 10 to the power of number 8 cycles, which is 50 megapascal, and the lowest for metal is 10 to the power of 8 number cycle, which is 62.5 megapascal. Next up is ways to overcome the fatigue failure. Ways to overcome the fatigue failure is with proper engineering design. Engineers should utilize models and expertise to optimize the component design for long useful life in order to maintain stress below the fatigue threshold. They can ensure that fatigue will not contribute to overall failure of a system during estimated life of the part by prescribing the proper alloy thickness, form, and grain consistency to meet cycle loading criteria. To help ensure safety and crack growth calculation and non-destructive inspection are implemented as well. To explain this, we calculate and estimate when the lifespan of an item will last for fatigue growth. And the second way of overcoming the fatigue is try testing the material. We should try pushing the materials to their limit under realistic and symmetric condition and analyze the crack growth and corrosion. We should also observe the crack growth and propagation and where it originate from. This helps to pinpoint where the location of failure is from and where the location of crack growth is prominent at, so we can find the solution or change the material instead.